Hi there, this is Ryan Malloy here at the Worldwide Center of Mathematics. In this video, we're going to discuss one-sided limits in calculus. So here we have f of x, which is a piecewise function. When x is less than 2, it is defined by x squared. And when x is greater than or equal to 2, it is defined by this weird-looking function sine of x to the power of x squared. Probably something you've never seen before. What we're being asked is the one-sided limit as x approaches 2 from the left of f of x. So recall that when we're dealing with limits, we are not entirely concerned with what actually happens at the function at that point. We only want to know what the behavior of the function is as it approaches that value. So with that in mind, consider that if x is approaching 2 from the left, then within this limit, x will always be smaller than 2. So what that tells us is that we can simply use this definition of f of x and completely ignore this crazy sine of x function. So this is equivalent to the limit as x approaches 2 from the left of just x squared. Well, this is easy to compute. We can simply plug in 2 for x squared and see what we get. 2 squared equals 4. Easy enough. Now, the other situation in which one-sided limits are useful is when we have a function of x in the denominator. So here we have g of x is equal to 1 over 1 minus x. At the point x equals 1, we have an infinite discontinuity. What we want to know is if we approach 1 from the right side, or from the positive side, is the function going to positive infinity or to negative infinity? We could simply graph this on a calculator, but assuming you're not able to do that, we should be able to find a rigorous mathematical way of determining if the function goes to positive or negative infinity. So let's rewrite this. We've got 1 minus 1 plus. This may seem like a bit of a weird notation, but let's just see where we're going. 1 plus, what does that mean? It means some value that is infinitely close to 1, but slightly larger than that. It might be helpful to think of this as being 1.00001 or something like that. But what this tells us is we have 1 in the numerator, and when we have 1 minus some value that is slightly larger than 1, what we get is something that is very close to 0, but slightly smaller than that. So it's a very slightly negative number, is one way to think about it. So this is essentially equivalent to negative 1 over 0, which tells us that this function goes to negative infinity as we approach 1 from the right. My name is Ryan Malloy, and we've just discussed one-sided limits in calculus.